Hi, this is Trinad, and I'm going to explain you about the Holevo information of quantum channel part 1 as part of our project in quantum course. Firstly, to start with, what is quantum information all about? We already came across several classical and quantum entropic quantities. Each of these entropic quantities are static. Let us now explore some dynamic entropic quantities. The basic idea is we send one share of state through a channel and then maximizing the computed static measure across all possible states that can be transmitted through this channel. That is all the maximum or all valid inputs. And now let us consider an example by taking a pure entangled state. Now say that we have a quantum channel. Now we want to measure the mutual information that the resulting states and then maximizing over all the valid possible input states. Now the dynamic information measure of the channel's ability is to preserve the correlations. In simple layman terms, that is just about the ability of the channel to preserve correlation. What is Holevo information of quantum channel? It is dynamic information measures of quantum channel in terms of classical correlations. Let us take an example of Alice and Bob. But firstly, before that, let us discuss about ensemble interpretation of quantum mechanics considered to the quantum state description to apply only to an ensemble of similarly prepared states rather than supposing that it exhaustively represented as individual physical system. The definition itself is self-explanatory, so I'll move on. Now, coming to the example of Alice and Bob, let us get back to the famous example. Now, say that Alice has an ensemble state which is represented by as the notation given, and then all the rho x's are acceptable inputs to the quantum states, and px of x represents the probability of that particular state being given as an input. Now, Alice can prepare some input, some density using those ensemble matrix, which is given by the formula, like famous formula. Now, the main question is how much information can Bob get out of the state sent by Alice? The expected ensemble adding to the notation, some of the notations are the expected notation ensemble of the LS state can be represented as follows. The state that will be observed, like that will be passed when it passed to a quantum channel A to B and running from A to B will be given as this. Now, our main goal is to somehow measure the ability of this particular quantum channel to preserve correlation, classical correlation. But how do we do that? The answer is Holevo information of quantum channel helps us to do this. For a particular input ensemble that Alice chooses, the correlation between input output correlation information is the Holevo information. Now say that the input we choose should be such that the Holevo information is the maximum. That is what we call as Holevo information of quantum channel. Now that is mathematically represented as here. Like note that the inputs which are given should be valid inputs. Now, let us talk something about the additivity of Holevo information of specific channels. Already we know the importance of additivity in terms of how it plays an important role in understanding what we think. But is Holevo information of quantum channel additive? No, it does not. It is not additive. In fact, most of the people will think that like we may mislead into the fact one of the misconception is it may be because of classical correlation because we keep talking about classical correlations when we talk about Holevo, but instead it is quantum correlations which may enhance the Holevo information. The additivity of Holevo information may not hold for all quantum states. There are only few set of quantum states for which it holds. One of the classic example that is which is well known is entanglement breaking channels. The theorem goes this way. Suppose consider an entangled breaking state and another channel. Then the Holevo information of the tensor product is the sum of individual Holevo informations. The proof is much detailed, so I am accepting the proof due to the constraints of time. And now, one of the more information, just to brief about Holevo information, is consider that Alice is sending ensemble through a noisy channel as given in the diagrammatic notation